Okay. All right, so again, we're in session 10. And again, if you have questions, feel free to just jump in and ask the question, just unmute yourself. You'll see the COVID-19 discussion. So this is our session overview. COVID-19 discussion is down here. Let me just click on these. So what you'll do is you'll write down below in the reply area, you'll write 2 paragraphs. The first one will be on this Washington Post article on why we're trying to spread the curve. So this is on social distancing. And then you can either read The Atlantic or watch this video for the second paragraph. And it will describe why COVID-19 is such a problem for us and why it's not just like the flu, and why it's so contagious. And so make sure you look at both of those. You will get out of the class early today so that you can work on that. Any questions on this? If you have questions and you're too shy to jump in, you can always type them into the chat. Oh, here it is. I'm here with James. Is that okay for me now? Oh, Rachel. Yes, Rachel, you are fine. Okay. Okay, let's get to our PowerPoint. Wrong PowerPoint. Here we are. Okay, so let me get to, I think we left off here. Does that look familiar to everyone? I see heads nodding, so I'm going to take that as a yes. We're talking about naming species, and this guy called Linnaeus came up with the species naming system. He did not like it that people from one part of the country could call one species one name because somebody named it that, and then if you went to another place, the exact same species would have a different name. A really good example of that, let me show you a great example of crazy names. Cheatgrass. So cheatgrass is an invasive plant. It kind of looks like some of the grasses you'll see around here. There is a very similar grass in this area, and actually you can find some of this grass around in Arizona. But cheatgrass is all over the United States. It's actually native to Eurasia, so the Turkey area. But it came over here, and it's an annual plant. And one of the reasons why we have so many wildfires in the United States these days is because of this grass. And it's a huge problem. So what happens is right now it's all green and nice for the cows to eat, and it's got these seeds get in your socks, and they're a pain in the rear if they get in your socks, especially when it dries out. But the problem is it's an annual plant. And that means that it grows, it germinates, grows, and then dies all within one season. So what happens is by end of May or early June, you've got all this brown dead grass early on in the year, and it's got all summer to find a way to find a spark and then cause a big, massive wildfire. So here in the West, wildfire frequency is supposed to be roughly anywhere from 40 to 100 years. Where this grass is, that has reduced its fire return interval to about once every 4 years. So big increase in wildfires. And so that's a problem. A big problem. Well, a lot of people call it cheatgrass, depending on where you're at. But if you go to, say, southern Utah or even into Nevada, some people call it June grass. And all of a sudden, you've got multiple names for a different type of grass. And in Washington, they have their own name. No worries, Cassandra. Gotcha. Anyway, there's lots of names, common names for this grass, and no one knows if you're using those common names if you're talking about the same grass. And so this guy Linnaeus came up with a system, a naming system that focuses on using a dead language so that we can't confuse words. So why did he use a dead language to name everything? Well, back when I was a teenager, it was common for, if you thought something was cool, you would say, "Oh, that's bad, man," meaning that it was good. But you see the problem there? Words can change meanings as languages evolved. And so Linnaeus decided to use a relatively dead language in Latin in order to prevent that kind of change. And since no one really knows how to speak Latin really well, because it's not used much, it turned out to be a really good language to use. It uses, the naming system uses the genus kind of as a family name, and then this thing called the specific epithet is the individual name. So for me personally, if I were to use my first and last name as a binomial system, my last name, my family name would be Klein. That would be the genus. And my specific epithet would be Nathan. Okay. But when you talk about names for different species, they flip it so that the family name is kind of first. The genus is first, and then the specific epithet is second. You always italicize them when they are written out. So if we had Homo sapiens here instead of this other one, Homo sapiens would be italicized, and the genus is always capitalized. And as you know, we've been over this probably a half dozen times in class. It falls right into the hierarchical system of domain, kingdom, phylum, class, order, family, genus, species. Dumb kids playing catch on the freeway get smashed. And so everything falls into these different, this hierarchical system that we call taxonomy. Okay. Just a second. I've got a little one who's trying to get my attention. 1 second. Come here.
Oh, there it
yes. Is. Come here. I want to introduce you to my class. I want you to introduce you to someone. This is Charlie, my son. He's also home from school, I guess, for the rest of the year. And he wanted his blankie. So say hi to everyone.
Hi.
What you doing right now? Are you outside jumping on the trampoline?
Yeah.
He's jumping on the trampoline. Okay. I'm going to send you off so I can finish my class. Okay. Okay. All right. So, so we've named different species. Now we've got to find out how they're related. Okay. So we're going to talk about that. You've probably seen family trees, right? Family trees are normally at this phase in the class, I would have you all pull out your phone, your smartphones, and we would see if any of us were related. Unfortunately, we're not close enough to each other in our physical proximity to figure out who's related to who. But phylogenetic trees are basically family trees. You can see the word genetic in there, and that simply infers that there is a genetic commonality between us. And if we looked at our genes, we would have very, very, very similar genes as a result. It also means that we have common ancestors. And I think if I didn't cover that in class, at one point, I want to make sure I cover it now. So my sister and I have a common ancestor in my parents. My cousins and I would have a common ancestor in my grandparents, and so on and so forth. And so when we talk about common ancestors, we have to think back. And that's important when we consider how evolution occurs. So at some point, a sheep and a cow had a common ancestor, okay? These two deers, a red deer and a reindeer, also had a common ancestor. But it isn't until you get way back here that a sheep and a reindeer have a common ancestor, okay? You got to go way back here. And you can map that out again, species, genus, family, order, if you'd like. You do not have to include that, but you could. Here's another one. So you've probably heard there's some people who would say, I'm not from a chimpanzee or a monkey, okay? Well, no, you're not from a chimpanzee or a monkey. What evolution is simply saying is that you have a common ancestor with either a chimpanzee or a monkey. And that's just what evolution is interpreting. The molecular or genetic data seems to tell us, okay? So that's a phylogenetic tree. The study of phylogenetic tree is a something called cladistics, okay? Cladistics is the study of trees. There's another group that's very closely related to it. In fact, they're kind of embedded in this. It's called taxonomy. It's the identifying of species through cladistics. So you may see that term taxonomy in your text. Cladistics is a way to trace evolutionary history of a group by using shared traits derived from a common ancestor. So specifically, these are shared traits. Now, those traits could be genetics. So you could have a phylogenetic tree, but you don't need to use genetics. You could use the fact that many species have a radius and ulna bone if you wanted to. What was the first organism that had a radius? I'm sorry, radius is on your thumb side, and ulna. Where did that come from? Which was the first organism that evolved that trait? And that would be our common ancestor. And then you can put it into something that looks very much like a phylogenetic tree or a family tree, and they call that a cladogram. So just to be clear, a phylogenetic tree would be a type of cladogram. So here is a cladogram that specifically looks at traits rather than genetics. This one is amniotic egg, internal fertilization. Where did that come from? Well, snakes and lizards had a common ancestor where that first evolved. Then you had newts that had a common ancestor with snakes and lizards that had lungs, or vertebrates all the way back from an eel, and we all had common ancestors that included that. Here's another example of gizzards. That's a type of stomach that you see between crocodiles and birds. Oh, who remembers the missing link between crocodiles and birds? I want to see if you guys can find it. So first person, I want to see someone type it into the chat. What is the name of the missing link between reptiles and birds? Look back in your notes. Dinosaurs. Archaeopteryx, Adam, good job. Archaeopteryx, do you guys remember that? It was a dinosaur that had feathers, and we considered it the missing link between dinosaurs and birds. So Archaeopteryx, good question. I like to ask that question on quizzes and final exams. So that's one to make a mental note of. So this idea that we have common ancestors as we go way back, I mean, look way back here, all the way to mammals, right? Okay. Mammals are a group, an offspring group that has hair and mammary glands. And so we would have, all mammals would have a common ancestor with someone that has, or an individual that has mammary glands and hair. And then eventually all life. So this is the eukaryotic domain, bacteria domain, and archaea, the extremophiles. If we follow this family tree, eventually we have one common ancestor that evolution seems to suggest all life originated from. So nice big family tree that includes all living things. So this group is 7 to 8 million species, and then these two groups down here is estimated to be around 60 million different species that all may have originated from one life form. So kind of crazy. All right, so that is the end of our chapter for this week. Feel free to go back and review that online. Make sure you know it. Today, again, go on and make sure, take time right now just to take care of the discussion. Get it done right away so you don't have to worry about it for the rest of the day. I will stay on here for a few minutes. If you wish to ask me questions or talk to me about anything, feel free. Again, this will be posted on my YouTube page. So if you want to go back and re-listen to me talk again, which I know you want to do, feel free, okay? Other than that, questions, let me hear them. If not, have a great day. You're free to go.
When is the discussion due?
Today, your initial post is due today, and then on Friday you should respond to at least two of your classmates' posts.
Hey, so I wasn't here on Monday. What did I miss?
So I will copy the link. My recording of our class did not save properly, and so I'm going to copy the link from my 8 o'clock lecture, which is the same stuff. I'll post it to you. Whenever you miss class, you can go on to my YouTube page, which, oh, I haven't posted on your page yet. Let me put that on. I'll put my YouTube page on main screen in our Canvas class. You can just go to that and look for live videos, and it should post the videos on there for you to see. Just a second, and I will put that information right now on. Let's see. There we go. Okay, so, and let me also copy the link from Monday's class, so on our chat here where you can find it. So here's my YouTube page. If you go under videos, oh, playlists, sorry. Let's go to playlists. Here it is, right here.
Okay.
Let's see. And so this is from 3:30, and I will copy the link in the chat for you. There you go. So you can watch that
Great.
and get what you need. And if you have any questions after watching that, please send me a message. Okay.
Alrighty.
Um,
Thank you.
one other thing, real quick, for those of you who are still here, um, I I did find out that I'm going to have access to my office phone. I actually set up another phone number that if you want to call me, it'll contact me here at my desk, and you don't have to leave a message. So, okay. Any other questions? Okay, have a good day.